Hi there, in this video we are going to go over how to write and use the equation of proportional relationship. Alright, so a proportional relationship has an equation form of y equals kx. The ratio y to x is called the constant of proportionality, and it is represented by the variable k. All right, so we want to tell whether or not these examples from 1 to 4, whether these equations represent a proportional relationship. So, in other words, do these look like y equals kx, okay? And then if so, identify the constant of proportionality, or k. So number 1 says y equals 2x. Well, this does look a lot like this. So, yes, this is proportional. And if we write out y equals kx at the top, you'll notice it looks very similar. And in the k spot, okay, there is 2. All right, so yes, k equals 2 here. And number 2, if you write y equals kx, you'll notice that this equation does not look like what is given here. Okay, there's a plus sign here. And in our initial equation, there is no plus sign. We're multiplying. So this is not proportional. The next one, if you write y equals kx at the top, yes, you'll notice this is a proportional relationship. It is written in the format y equals kx. And then k equals 1/3. All right, next here we have y equals 2x plus 4. So because of the plus, automatically we know that this is not a proportional relationship. It does not look like y equals kx. All right, number 5, we have determine if the relationship is proportional or not, and if so, write an equation representing this relationship. All right, so hopefully you remember that k equals y divided by x. So in order to figure out whether something has a constant of proportionality, or in order to see if something is proportional, right, it needs to have a k. It needs to have a constant of proportionality. The ratios need to be the same. So here if we do y divided by x, all right, that's how we find k. Let's look. Here we have 50 divided by 1, 70 divided by 2, 90 divided by 3, 110 divided by 4. If we go to divide, 50 divided by 1 is 50. 70 divided by 2 is not 50. So because these ratios are not equal, there is no constant of proportionality. So there is no proportional relationship. So here, this doesn't show a proportional relationship because the ratios of y to x are not equal. So there's no constant of proportionality, which is k. Alright, number 6. Water is dripping from a faucet into a bowl at a constant rate. The number of milliliters of water in the bowl y and the time in seconds x are shown in the table. What is the constant of proportionality? And write an equation to represent the scenario. Alright, so k is equal to y divided by x. I'm going to actually write it so that it's across. Y divided by x. So we're going to do 320 divided by 20. We're going to do 560 divided by 35. 720 divided by 45. 960 divided by 60, right? So all of our ratios are y divided by x, and we're going to see what we get for k when we divide. All right, so when we divide 320 divided by 20, we get 16. If you divide 560 divided by 35, you get 16. So for each of these, when you divide out 720 divided by 45, 960 divided by 60, you get 16. So the constant of proportionality, K, is 16. Now remember, we do Y per X, right? So when we label Y per X. So Y is the milliliters in the bowl per second. Milliliters in bowl per second. Okay, so this is your K. K equals 16 milliliters in the bowl per second. And then your equation, which is supposed to be written in the format Y equals KX. We're going to replace K now with what we know it to be, which is 16. So here is our equation. So, in other words, every Y value that's here, right, you can get that by multiplying these X's by 16. Okay, that's what this equation literally says. Y equals 16x. Take all of these x's and multiply them by 16, and you will get their y's. All right, number 7. The relationship between the distance and the time is proportional as shown in this graph. Write an equation that represents this relationship. All right, so let's pick out some points. I'm going to pick this point here, which is 1, 49. I'm going to pick this point here, which is 5, 245. And I'm going to pick this point here, which is 9, 441. And then I'm going to take my x's and divide them. Actually, we're going to take the y's and divide them by the x's. Okay, so 441 divided by 9. 245 divided by 5. 49 divided by 1. And you should get 49 for each of them. So because of that, you got K to be 49. And let's make sure we label. It's 49 Y per X. So 49 miles per hour. Okay, Y per X. All right, write an equation that goes with this relationship. So we're going to write it in the form Y equals KX. In place of K, we're going to put 49. All right, moving on. Number 8, John started working a new job, working 15 hours a week. Write an equation to represent the scenario relating John's total hours Y to the number of weeks X he worked. Okay, so we know that our constant of proportionality K is equal to Y divided by X. Here it is labeled that the hours are Y and the number of weeks is X. Okay, so always think about your ratio, what it would be in words. So we're given a number here, 15 hours a week, 1 week. 15 hours in 1 week. Write an equation that represents the scenario relating John's total hours to the number of weeks. So now we're going to do 15 divided by 1, and you get 15. All right, so, which is our K, right? Once you know K, you just input that in Y equals KX. We're going to replace K with 15, and now we get our equation, Y equals 15X. All right, next here we have Luke earned $54 after mowing 3 lawns. Write an equation comparing the earnings to lawns. That's our ratio. So we're going to put earnings at the top over lawns. Our earnings are $54. Our lawns are 3. Okay, so now we're going to do 54 divided by 3, and we get $18 per lawn. And let's make sure we are aware that this would be y and this would be x, right? Because our k is always y divided by x. All right, so once you get this to be k, now we're going to write our equation to answer the question, which y equals kx. We're going to replace this k with 18. Using the equation above, how much would Luke earn after mowing 7 lawns? So lawns we labeled as the x value. So we're going to plug in 7 for x. So here's our equation. We're going to plug in 7 for x, and then we're going to solve. If you think about it, right, $18 for 1 lawn. For 7 lawns, you would have to multiply 18 by 7. And then we get $126 in earnings. Okay, and the number 10, a recipe calls for 3 ounces of flour for every 2 ounces of sugar. Find the constant of proportionality and write an equation to represent the proportional relationship between the number of ounces of flour, y, and the number of ounces of sugar, x, that the recipe calls for. All right, so we know that k equals y to x. All right, we know that y is the ounces of flour. We know that, we know that x is the ounces of sugar. All right, so we are given 3 ounces of flour, so that's going at the top, 2 ounces of sugar, that's going at the bottom. So our K is 1.5 when you divide it out. And it's 1.5 ounce of flour per ounce of sugar. All right, so this is our constant of proportionality, 1.5 ounces of flour per ounce of sugar. And then our equation, which would be written in y equals kx format, would be y equals, replace the k with 1.5x. And you don't actually need the parentheses, y equals 1.5x. Alrighty, so that's that. Let's go on to the last question here. Percy rides his bike 11.2 miles in 1.4 hours at a constant rate. Write an equation to represent the proportional relationship between the number of hours, x, and the distance in miles, y. So first we know that k is equal to y divided by x. In words, our ratio, y is the miles and x is the hours. All right, and we're given 11.2 miles, and we're also given 1.4 hours. So when we do our division, we're going to do 11.2 divided by 1.4, and we get 8, and it's y per x. So it's 8 miles per hour. That is k. Once you get k, right, just so we're aware, once you get k, you plug it into your equation. So we get y equals 8x. All right, so that's all. Hopefully you learned how to use the equation with proportional relationships. Thank you for watching.